Welcome everyone to Knox Game Design for November 2025. My name is Levi Smith. So this month I'm going to be talking about joints and specifically hinge joints. So how can joints be used in a game? In a 3D game, they can be used for things like doors or pinball flippers. I made a game a long time ago called Earthball Pinball Game, and I actually used joints in Unity to implement those flippers. Really didn't have a great understanding of it at the time, so I thought this would be a good time to go back and look at joints more in depth. So there's a few different types of joint components in Unity. I don't think many people talk about them very often, but you got character joints, configurable joints, fixed joints, hinge joint, and spring joints. And for the demos I'll be doing today, I'll be talking about the hinge joints. And the hinge joint itself has many different properties. Some of the ones that we'll be looking at is the anchor position, the axis, spring, limits, and brake force. And here's a couple of links for more information on the different types of joint components. So if we look at the website, here's an introduction to joints in Unity right here. A lot of good information, and these are the different joint properties right here. And then if we look at this link, here's a description of all the properties of a hinge joint. So there's a lot of different configurable options for this joint. So the first demo I'm going to show off is basically doors using these joints. So if you click on one of these doors in the scene view right here, you can come over here on this side, and here's the hinge joint property. So this really doesn't have any scripting to it at all. Like I mentioned earlier, here's the anchor position, the axis. So we're going to have that 001 Z, 1 for Z axis. So your Z axis is the blue one, so that's going to make it rotate on the Z axis, which is what we want. Not modifying any of the spring properties, leaving the min and max and all these options set to default. So let's go ahead and play this. Okay, so this is what it looks like right here. So I got the scene view over here on one side of the wall, and then the game view on this side. So I got this little character, so he can just like push the door open, and it opens up and closes. And then he can go through the other door like this, and it opens up. So there's no spring to it, it just opens and closes. I can go back to the back side, and you can push it this way and go back through there. You can come over on the front side door and push it open like that. So that one did have a little bounciness. It might have collided with the wall itself, but yeah, that's basically how a default joint works. It basically rotates. So then down here I have just the door by itself. So you can see without any of the walls, you can just like keep pressing it forever, and it will keep rotating around that axis. And you see it's got a little bit of physics in it, or it'll keep moving a little bit by itself. But yeah, this is basically a joint. No scripting aside from just the player, which is just using basic translates. I'll go ahead and show in Blender. This is how I modeled the room. So just basically use like these cubes for walls. You can press tab to go in between edit and object mode. So basically all these walls are the same, like that. Next you press Z and view the solid room like that. Zoom in with the mouse wheel, and press Z and go to material preview, and you can see what it looks like in Unity once we import it into Unity right there. So basically I just what I did is for this middle wall right here, I used this add modifier, and you go down to this wrench icon, and let's see here. I think I pressed wrong. Yeah, you can go to generate Boolean. Get rid of this one. Then under Boolean, you have intersect union or difference. So pick difference. Then you need another piece, which is If you saw it earlier, there's another piece which I have hidden here. So this piece right here is what I use to cut out the door holes right here. So you can just do like G, Y, and you can see where that, use that to cut out that wall right there where the door goes in. Then I have a separate, see, open, recent. I have a separate door. So file, open, recent, door. So it's very important to make the door a separate model. But you can see right here, the important thing right here, if we go into the modeling view, the important thing is that the origin or the 0, 0, 0 point is the position where this thing's going to rotate. So we can go into object mode and like do R, Z. So that's how it's going to rotate right there along the Z axis. So really, it probably could be moved a little bit to the left right there, but then you got to make sure you apply that transformation. So that little orange dot right there, that's where it's going to rotate around. So that's why it's important to have your door a separate object. If we look back in Unity, you can see down here in the hierarchy, here's the doors that I added. So you can click on any of those and you can see them in the game. And basically what I did is I just pulled that model in, that door model in to Unity. And then I added like the mesh collider and then the rigid body and hinge. The rigid body may automatically be added when you add the hinge joint, but it's just important to make the axis 1 on the Z. Otherwise, it's going to rotate the wrong way. So yeah, basically just duplicated that for each of the doors. I duplicated one door into the 3 more doors. But really, you'd probably want to make that a prefab if you're making this into a real game. So another example of a joint, using a joint, is pinball. So what I did is I modeled the simple little playfield in Blender. Tried to use the real dimensions. It's important to attach the mesh colliders to the playfield, otherwise the ball will drop through the model. And also give it a little bit of a tilt so the ball will slide downward. As with the door, make the flippers a separate model. That way you can set the origin point where it's going to rotate. Make sure you add your collider. You can either do a mesh collider or a box collider. I found out it's a little bit easier to use a box collider, even though the flippers aren't perfect rectangles. It just works a little bit better. If you do use a mesh collider, make sure it's convex or it will complain. And then you add the hinge joint component. For the ball, I use just like a simple Unity default ball. Set the size to 0.027, which is what I found was the size of a pinball in meters. Then make sure you attach the rigid body, the sphere collider. And for the input, create an input handler for the left and right mouse presses. Make sure you check for when the key is pressed and released for both the left and right. You can either use a mouse input, use a keyboard input, or whatever other types of input, gamepad. So here's a little bit of the flipper script right here. So I created a custom script called flipper. Has the rest position and press position. So that press position is going to be different whether it's to left or right. So the left is going to be -45. For the right, it's going to be +45. You're going to have an is pressed instance variable, and then here's the reference to the hinge joint. You just basically drag it from the component into this script. Here's the flipper hinge joint right here. Set the anchor to 0, 0, 0. You can modify that, but I'd rather have the rotation point set to the origin in Blender. If you do move it in Blender, just make sure you apply the transform. That way it centers it back up on 0, 0, 0. Again, we're setting the axis to 0, 0, 1, so it's up. So for the flipper, we're going to use a spring, and we're also going to use the limits. So the limits are set based on the values in the flipper script. And we assign the flipper script to both flippers, and then we set the references in the flippers in the game. So I have a game manager in this one. So then I pull the left and right flipper into the game manager. And here's the game manager. So basically we're handling the player input. right here. So this is where we're doing input. This is just handling key presses. So input, get key down, left arrow. So it's going to make the left flipper is pressed true. If the left arrow is released, then we're going to set the is pressed instance variable of the left flipper to false. If the right arrow key is pressed down, then we're going to set is pressed to true. If the right arrow is released, and we're going to set is pressed to false. And this is where we have got the game's manager right here, left and right flipper references pulled into that in the inspector. So basically I have these as hinge joint demo 1 and hinge joint demo 2. I'll have these in a source code repository, so anybody can look at the code. Really not much code to these. It's more of the assigning of the hinge joints. So here's the hinge joint 2 demo right here, the pinball. So I'll go ahead and start this up. And this just randomly spawns balls at the top. A little bit of work needs to be done on the physics, but you can see here when I'm pressing the keys, right key, left key, that the flippers are going to the 45-degree rotation angles. And actually hold them both up at the same time to trap the ball. So in a real pinball game, there'd be a little bit of space between the two flippers. And yeah, there needs to be some modifications to the physics. You can add a physics material to make the balls like slide a little bit better, where you can hit them all the way back up to the top of the play field right there. And there's just like an infinite number of balls that spawn. So, but this is just a demo to show the hinge joint. So yeah, we've got a play field right here. This is the actual model of the play field, and the walls within those two little like sheets right there. And those are I just call them walls. And there's the play field. The play field is like the box around it. And then we got flipper R, which is the right flipper, and flipper L, which is the left flipper. And then you can see under flipper, again, we have the rigid body. I just left all these as default. Here's our hinge joint right here. And anchor 000, axis 001. Got the limits 00 right now. And spring 000. But you can see in this one, I got a script called flipper. Go ahead and open this up. I was talking about this a little bit earlier. So for each flipper, I'm going to have this flipper script assigned. So it has a rest position set to 0, pressed position, Boolean is pressed, flipper strength, got it set to 100, flipper damper set to 1 float, a hinge reference to the hinge joint, reference to the spring and the joint limits. So whenever this thing starts up, we're going to set is pressed to false. The spring's going to get a new joint spring. Joint limit's going to get a new joint limits right there. The minimum position is going to get the rest position, and the maximum is going to get the press position. So that's pulled in directly from the inspector. So you can see for flipper R, for the flipper script, we got 0 and 45 right there. And for the left one, we got 0 and negative 45 right there. So those get kind of set dynamically based on which flipper it is. Here's our update, just setting the spring reference to the flipper strength, damper to the flipper damper. So if the flipper is pressed, we're going to set the target position to the press position. Otherwise, the target position is going to get set to the rest position. And then we're assigning the hinge joint spring to that new spring value right there. And that's basically it. I guess the only other thing I'll mention is like if you click on one of these flippers, you can see right here I have the box collider. And you can go to edit collider right there. And you can really like zoom in. Got to be kind of careful. Got to play with the sensitivity. But I just kind of lined up the flipper around that box collider around the flipper. It usually does a pretty good job of aligning it right there. But I don't know if I still have it in here. There's also you can use a mesh collider as well. The box collider is probably a little bit more efficient in doing calculation, but maybe not perfectly aligned with your flipper right there. Game manager just has public references to your left and right flipper, and then the handle input right there. And if we go, so I do have a game manager object right there. So you just pull in your right flipper here and your left flipper here. And the only other thing I'll mention is in your flippers. So you see I have a hinge joint reference right here. So this is flipper right hinge joint. So basically do that, you click up here on the hinge joint and you drag it in here. That creates a reference back to this component right here. That way you can reference this hinge joint in this script. But there's a lot of different like properties, attributes that you can play around with, which if I was to make this into a full game, I'd probably play around with the bounciness of the ball. And yeah, no, I didn't mention there is a break force as well. So that means if something with a certain amount of force can break this flipper off, and it'll go flying off, which is probably don't want to do that in pinball. But maybe if you have a door or something, you want the door to be broken off with an explosion or something, then you can play around with those values right there. The only other thing I'll mention, this is my new LD Smith Games site that I created with Angular and MongoDB, ldsmith.games. So you can just search Earthball. So this is the game that I created I think back in 2013 or sometime. It's been a while. You can click play online right there. And this is kind of more of a full, not completely full. Yeah. I developed this in 2013, updated it in 2019. But you can maximize that right there. Saturn. But you see how the flippers. Saturn. You see I have the flippers on here, and I might do a longer talk just on pinball itself, but I didn't want to do a whole talk on this one. Had this talk to be on the flippers right now. So yeah, so that's going to be it for Knox Game Design November 2025. Yeah, hopefully everybody found it interesting. Just a short talk this month. Hope everyone has a great Thanksgiving. Yeah, and hopefully I talked about something that people might have not heard about hinge joints in general in Unity before. I'm not sure if there's a joint component in Unreal or Godot, but that's something I'd be interested in. Maybe looking into to see if there's an equivalent in Godot and Unreal. But you could probably almost implement your own just using basic rotations and setting the constraints and things like that. So anyway, appreciate everyone out there listening and watching.